Okay, so let's consider this curve, and it comes with a parameter t. And our question is that given parameter actually the arc length parameter? So how should we go about figuring that out? Well, we know in general that no matter what that parameter is, the arc length will be given by the formula that we just talked about, which is this. So if the curve is parameterized by arc length, what does that mean? Well, it means that t is actually s. So if the curve is parameterized by arc length, we know that this s is equal to t. Right? It's saying the arc length parameter is the time parameter. And this actually allows me to rewrite this by just substituting in s for t. We get this. So this may look a little weird, but it's not really hard to see where it comes from, hopefully. So the question is, well, okay, fine. What do we do with this? Well, remember, we have this nice result, the fundamental theorem of calculus, that tells me that if I differentiate both sides with respect to s, what I really am trying to do is I'm trying to differentiate this definite integral. And the fundamental theorem of calculus tells me this is not a difficult task to do. When we differentiate this, all we have to do is plug in our s for tau here. And so this tells me that if the curve is parameterized by arc length, then the magnitude of the velocity, the speed, must be 1. So this is a nice result. Let's actually then say, okay, well, look at this actual result here. So if the speed is 1, what can we do? Well, we can do this entire argument in reverse, essentially. And we can also say, essentially by running this argument in reverse, that if this r prime of tau is equal to 1, and let's say r prime of t, we'll use our original parameter, then the curve is parameterized by arc length. So we started by saying if the curve is parameterized by arc length, it must have unit speed. This does not mean find a value of t for which r prime is 1. It means that r prime, the magnitude of r prime of t, is the number 1 no matter what t you're looking at. We also then can run this argument in reverse and say that if the curve has unit speed, then it must be parameterized by arc length. So this result is summarized in the next slide.